Are we live now? Hey, what's up, guys? How are you all? So, how many people do we have here? Like 14 right now at this point, I guess. And hey, Abhinav. Hey, hey, Lifer from Gaming. Hey, Kirthana, how are you? And come on, like only we have got. Okay. So I can wait for like a minute or two. Meanwhile, I'll setting like no, I'll be setting up my this entire setup here. And all right, I think we're good now. I am doing great. Thank you so much for asking. Hi, Mansoor. Hello, Mr. Suspicious. This again is not working. Whoa, this again not working. It is not working like Oshin. The screen sharing feature is not working for some reasons. Yeah, now it is working, I guess. So I guess like you people can actually see my screen right now. Can you? Welcome, sir. Thank you so much for welcoming me. And hello, Shreya. Hello, Digital India. How to get okay? Go on link provided on WhatsApp. They can okay. So tell me, sir, what do I need to tell you? How I guess like the moderator can help you with that. I guess, and also you can also you can reach out to your peers as well. I don't really have that information honestly. Digital India. So sorry. Okay, so I guess we are good right now. Okay, so let's get started, shall we? So this session will be all about, like two and n-dimensional arrays. So where exactly we were. So yesterday, what we saw, like how like goodness goodness of a of an algorithm, right? Based on cost function. This is what we understood yesterday, right? So your cost function for regression, the task was for the regression. I will gonna explain what exactly regression classification is just in a while. Okay, was what? Let me actually write it as j of w comma b 1 by n, right? Summation I is equals to 1 to n yi minus yi dash to the power 2. And here this yi was like what? Yi can be given as w transpose x plus b. I will gonna come back to it like what exactly this transpose is all about. Okay, and so this was your cost function, right? Cost function to determine the error between estimated and original values, right? So this is for regression. So we will be tackling today like how exactly the regression works, and of course how exactly it differs from the classification, and then we're gonna deep dive into how exactly your model and what exactly your model actually learns. We have already understood we made it quite clear like your model basically needs to learn about these parameters w and b, weights and biases, right? But how is the question here. Okay, so I will not gonna go deep into the architecture, or sorry, deep into the literature of mathematics in this session, but I will gonna give you a basic overview of how exactly things works. Maybe not under the hood, but above the hood, right? Okay, so now let's get started. So the first thing for supervised machine learning systems, so we covered three systems mainly in machine learning. First one was like supervised, unsupervised, and reinforcement learning. So for the supervised, you have features and label pairs. Then you have got only features in unsupervised. And then so reinforcement learning, basically you can have a scenario where both systems can work, either supervised or supervised based on an agent. But we will not gonna go in either of those two. We will be tackling in these 5 days only about the supervised machine learning system. Okay, and in supervised machine learning system, we've got two different techniques. The first one here we have is regression and classification. Okay, so if I may, let's actually talk about this regression here. What exactly the regression is here? Okay, estimating a continuous number. It is the most basic one-liner I can give you about regression. The most basic one-liner here, right? Okay, so estimating a continuous number. So when I say fx, when it actually gives you x, so this fx belongs to r, and this x can belongs to r as well. So I will gonna explain what exactly all of this all about, So if I say here fx belongs to r, it is basically or this fx can have value between minus infinite to plus infinite. That is what it means. Okay, and this, okay, and whatever the output, especially in the mathematical literature, this entire concept comes under the chapter of sets and relations. Okay, and when we are actually projecting two entities here, basically we have got here y. This fx can again expressed as follows: y is equals to mx plus c, or f of x. Okay, either I can actually write it as y or fx, doesn't matter. Of course, when we look into the bigger picture, bird orthogonal view or bird view. But this y or this fx actually belongs to minus infinite to plus infinite. So this is actually this, especially this minus infinite to plus infinite is a range for f of x. Range what your function can output between an interval, that is called a range. And when that range actually is a continuous value, well, in that case we will just regard that technique or regard that problem statement as a regression problem statement. Okay, so in this case, when we have this range for minus infinite to plus infinite, so in this case this is a regression problem. Why? Because the value or the output here for f of x is a continuous value. I hope this is clear. If not, just let me know. And if I plot this value here, fx and x, this is how the curve will just look like. This is a continuous graph or a curve, right? Any value is none of those value of for x is not breaking up anywhere. Sorry, for f of x. Sorry, for f of x is not breaking up anywhere. Okay, and now this is the range here. Okay, and there is another entity for the very concept. In this very concept, we call it domain. Domain is we take input from. So this domain, so if I put here, we have got here domain, right? And and we also got here range. So this domain is responsible for input, like input values. So this will be like, if we look into the bigger picture, or if we just zoom in a bit for ANNs or artificial neural networks, this domain will be responsible for what? Input layer, right? And this range, again, this range is what? Output values based on domain. Okay, and definitely this range will just gonna like now pop out on pop out on the, not pop it pop out, okay, not pop it but pop out, okay, on the output layer, right? Sorry, like sometimes my tongue can, like, it is not my first language, that is my excuse. Okay, so buy it, right? So okay, so like this is your input layer and this is your output layer. So when we talk about the domain, or when we talk about the input value, so we actually look, or we basically check like from which interval we can actually pass those values from. It matters actually. I will gonna explain how just in a while. And range is basically determines like what kind of value you are projecting or you are basically estimating. Okay, so when the range or the output of a function is continuous value, well, in that case, you will gonna regard that problem statement as a regression problem statement. That is regression. Is it clear to you or not? Just let me know. Is it or is it not? I think let's upgrade to arrange another class in English language. Sir, any in Hindi language? Can you tell me how to do the assignment? Yeah, I will gonna tell you. Ravi Tiwari is mentioning, I think let's upgrade to arrange another class in English language. So any in Hindi language. The irony here is, Ravi, like you literally are asking me this question in English. Firstly, you didn't even write anything in Hindi here, right? So I would suggest you, like, I don't know like where exactly you are facing the problem. Even either you tell me here like where exactly you are, like feeling tripping over, or okay, just let me know where exactly you are feeling any kind of confusions, right? Okay, so moving on. So this is a regression here. Okay, let's talk about classification. Okay, so for the classification, how exactly it will gonna look like? So for classification, when we have a class to predict, right, that is your classification. Okay, and in this case, even in this case, classes are discrete values, discrete or non-continuous values, right? Okay, so when I say this, like let us say we've got like you can actually go with the greater integer function. Okay, like gi of x, greater integer function. What exactly this is? So it only outputs integer values. Okay, so when I say, like, let's actually define this as a g. Okay, g of x will be like will gonna belong to only I, or integer values, right? Now comes the constraint here. What exactly the constraint you need to take care of? Okay, we basically we look for the cardinality of g of x. What do I mean cardinality? Cardinality basically means number of unique values, right? So let us say the cardinality for a b b a c. CA. The cardinality for this data set will be 3 because the number of unique values I can see here are 3. This, and this, A, B, and C. Okay, hence this problem statement and this problem statement can be further extended to a classification problem. How? Like if I have a task to predict whether a class is A, B, or C. So this is basically your classification. Is this clear or not to every one of you? Just let me know. Yes or no? Please let me know. Is this clear or is this not? Okay. Is this clear? All right. So in this case, right, let's actually go back here. Okay. And I cannot prove it right now, but for loss function, for classification actually looks like this, log loss. Okay. So it will be, let us say, like, no, I will just gonna represent this as L of X. Okay. Minus log of, let's say, I can actually write it here Z. I will gonna explain what exactly the Z is here. If Y is equals to, let us say, 1 minus 1, okay, 1 minus log of Z if Y is equals to 0. And I can also rewrite this equation as L of X minus log of Z, like multiplied by yi minus 1 minus log of Z, okay, multiplied by 1 minus yi. Okay, and if I put here, let's say if I put here y is equals to 1. Okay, let's actually put here y is equals to 1. Okay, it will be minus here. So if I put here y is equals to 1, like let's say in this case, this entire value, like this will be 0. Okay, and this will be only when, like, if just actually put here values here. So if I put y is equals to 1 here, this value will just gonna become 0, reduce to 0, and all you will be left with this here minus log of z. So that is what you have here. And if I put here 0, all you will be left with minus 1 minus log of z, and it will be multiplied by 1. Okay, so this is your log loss, right? And what exactly your z is here? So this z is nothing but your W transpose X plus B. I will gonna explain what exactly this is just in a while. Okay, so my question to you right now is, how many of you are familiar with the matrix multiplication or matrices structure in general? Like, have you ever heard about matrices in mathematics or not? Just let me know. Anyone? Yes. All right, that is great actually. So let us actually talk about that first. Okay, so you will be having a better understanding of what exactly I'm trying to propose here, or project here. Not really. I will gonna make you understand about it, So matrices and I can just simply write here matrices. That is great. So when I say matrix, so a matrix can be represented as M is equals to a square or something like this. And if I say here M cross N, it basically means I've got here M is equals to number of rows and N is equals to number of columns. Okay, so if I write here a matrix A is equals to 1, 2, 3, 4, 5, 6. The order for this matrix will be what? How many rows do you see here? 1, 2. How many columns do you see here? 3. 2 cross 3. Quite simple, right? So this is your matrix here. Now, when I say, let's say like you've got here A is equals to 1, 2, 3, 4, 5, 6, and it is 2 cross 3. So when I say A transpose, it basically means I am just gonna flip my rows with the columns and column with the rows. So flipping basically will gonna give me this 1, 2, 3, 4, 5, and 6. Okay, now it has become 2, 3 comma, 3 cross 2, sorry, not comma, but 3 cross 2. So now I have 3 rows and 2 columns. This is your transpose here. Okay, so basically you exchange those values. Now, in machine learning, everything is a matrix. So basically what we see here, even for the W, we have here matrix of weight vectors. Like basically we are calling a vector. So it's again like when I say a vector like this, W is equals to this is again a matrix, but with only one column. So this is called a 1D vector. Okay, all right. So in this case, what I can say here, what I can do here, like let us say you've got here a weight vector and you have also have a feature vector, right? And each feature will gonna have associated weight to it, right? So and also let us say like you've got here 3 features, or like I can say like let's say 6 features: x1, x2, and x3, x4, x5, and x6. And this is your matrix here. And I'm representing this matrix as x. So how many weights I'll be needing here? Obviously 6, W1, W2, and W3, W4, W5, and W6. The order for this is what? 2 cross 3, and even for this is 2 cross 3. Focus, guys. Okay. Now, there is a rule for matrix multiplication. The rule says if row and column number matches, multiplication is possible. Else, it's not. Okay. I will right now, if I say like, let's actually name this as M1, N1, M2, and N2. Okay. So if you notice here, like 2 and 3 are not at all matching. Like if I say here, like for order 1, for matrix 1 is 2 cross 3, right? M1 and N1. And even for the order 2, it is 2 cross 3. And this is for weight vector, and this is for X, feature vector. And now what we can do here, instead of taking W, why don't I actually take W dash? So W dash will gonna have an order of 3 cross 2, and X is already having an order of 2 cross 3. Now the multiplication is now possible. So when I say here Y is equals to W transpose X plus B, that is the reason. Because in order to carry out that multiplication or that matrix multiplication, it is only and only possible when rows and column values actually matches. Okay, is that clear to every one of you? Like, have I made myself clear or not? Just let me know. Sorry, like I'll be having a chocolate here, but just let me know, like if it is clear to you or not. I'm sorry. Okay, and this is nothing but your estimation too. So that is the reason when I write here Y is equals to W transpose X plus B, this is the reason here. All right. Okay. Now, coming to the point where I was like, this is your matrix here. And now, do we have only 2D matrices? Because now, if we talk about n dimensional arrays or matrices, what exactly those are? Focus. Focus. Okay. So let us say you've got this value here. Array A, or I can just simply write here array. Okay. And let us say you have this here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your matrix here. So the order for this matrix is 3 cross 3. So when I write this 3 cross 3, this is your 2D matrix. So do we have 3D matrix as well? Yes, we do. It turns out we do. Okay. So in 2D matrix, 3D matrix will gonna contain a 2D matrix in it. The way like it is containing 1D matrices. Like if you look closely here, like this is a 1D matrix, this is a 1D matrix, and this is also a 1D matrix. Yes or no? Similarly, 3D matrix will gonna contain a 2D matrix as well. Right? Okay, so if I write here 3D matrix, how exactly it will gonna look like? So let us say I am writing it as array 3D underscore. Okay, and now in this case, let us say we've got this, we've got this. Okay, so now let's see, like you've got here 1, 2, 3, 4. This is your first matrix. 4, 5, 7, 8. This is the second matrix. Can anyone here can tell me what will be the order here? Like what exactly the order will be here? Anyone here can tell me that? I'm waiting for your responses here, guys. I would like to know your understanding here, like the way we actually understand this, right? I would like to know your perspective here, like what do you understand by this? Like what exactly will be the order for this matrix, for this 3D matrix? Anyone here can tell me? Come on, I know you can tell me this, right? I'll be waiting for your responses. Come on. 1 cross 2 cross 2. Are you sure? Manav, you are so close, but just focus. Almost you are close, but focus. How exactly it will be 1 cross 2 cross 2? The only person I can see here is reaching to a right answer is Manav. So Manav, you are just close. Just focus here where exactly you are going wrong. And yeah, I think you will be there. Two cross. Yay! Okay, I got an answer. And the right answer has been given by Aishwarya Nair. Thank you so much, Aishwarya, for giving a right answer. So it is 2 cross 2 cross 2. Okay, let's actually make an analogy here. Let us say for this one, I've got here 1D matrix, second 1D matrix, and third 1D matrix. So it is 1, 2, and 3. This is again first row, second row, and third row. Right? Okay. Similarly, we've got here 1 2D matrix, we've got here second 2D matrix, and we've got here 1 and 2 rows. Okay, right? So we will be taking the order of this inner matrix here in this case, and of course the outer value of it as well. Like how many matrices do you see in this inner matrix? Like in this outer matrix. So it will be 2 cross 2 cross 2. Let me actually again tell you like how exactly it is happening. So this 2, like when I say 2 cross 2 cross 2, this 2 is representing the number of 2D matrices in 3D matrix. Okay, and now this 2 cross 2 is the order of that 2D matrix. Right? Okay, is that clear? Now let me again give you one brain teaser more. Okay, let us say we've got this here array, and if I have here this, so if I say here 1 comma 2 comma 3 comma 4 4 comma 5 comma 6 comma 7, 4, 5, 7, 8, 9, 10, 11, 12, 4, 5, 6, 7, 9, 19, 20, 21. What will be the order for this matrix? Come on. I know you guys can tell me. What will be the order for this matrix now? I need right answers only now, like order. I need the order. What exactly will be the order here? What are we learning about, sir? We'll be learning about TensorFlow just in a while because it will all gonna make sense, believe me. Okay, this matrix is important right now. Legendary bros. Okay, so 3 cross 2 cross 4. So yeah, so the order for this will be 3, 2, and 4. Okay, just in a while, like it will all gonna make sense. Just in a while, just take my word for it. 3 cross 2 cross 4. Right, so answer is 3, 2, and 4. Right, like I don't know why people are still getting it wrong. So this is first, second, and third, and each has an order of 2 cross 4. It has an order of 2 cross 4. So therefore the answer is 3, 2, and 4. Okay, that's fine. All right, so now what we need to talk about here is how exactly you can actually make this connection or this certain analogy with the help of, like, how exactly you can connect this matrix multiplication knowledge along with the TensorFlow and dense layer, which we will just gonna see in a while. Okay, what if inside matrix order is different? That is not possible. That is not possible. Well, in that case, we will gonna, like, when we say here, I am happy that you actually brought this question up. So when we say here, like this value is not here, like let us say, like this value is not here, like or you can say, like, you know, 2, okay, let's say 3 and 6, like something like this, right? Let us say like this is something we have here. Well, in this case, okay, we have got two options here. Either we can actually trim these two values, trim them. Okay, second, what we can do here, like these values here, these values will be filled with NA. NA basically means missing values. Like these values are missing. So order has to be the same for each matrix. That is actually a good question. And I hope this is clear to you, Manav. Right? If it is not, just let me know. NA basically means not available. Okay, so now, okay, now if I go back here, so like this is the overview of the mathematics you need in order to lay those, you like architectures. Like I know, like it's the very basic and bare minimum of what we just gonna understand about just in a while. Okay, so if I go back here, and if I here go here, so you can actually follow along, or you know, like, or you can actually code it out. Like you have the free hand here. So the very first thing you will be talking about is the TensorFlow. So what exactly this TensorFlow is? Okay, so even before getting into the TensorFlow, lastly, okay, let's actually nail down all the checklist for training an ML model. Right. So checklist will be what? Suppose like pre-processing the data, right? Like assume it like we have already accumulated the data from the internet or from other various resources, and now we are pre-processing it. I will gonna come back to it what exactly the pre-processing means, maybe like in tomorrow's session, because tomorrow's session will be about like 1.5 hours long. Okay, so because it will just gonna require you to understand about certain mechanism in order to deal with any kind of machine learning problem. So I'll be getting into more detail of it, like how exactly the pre-processing actually works, plus EDA as well. So I guess like someone actually asked me, sir, please tell me how exactly the assignment will be done. So that is where you can actually take the reference from. So please, if you cannot do the research on your own, wait for another 24 hours. Your questions will be answered. Okay, pre-processing the data, okay, and then preparing the data for ML model, okay, and then like I will just gonna like no, then training, next is fine tuning, and then we perform cross validation. But don't worry, like I will be covering up like everything here, each step. So if you are not familiar with these terminologies, so do not find yourself like don't get intimidated by those either. Like I will gonna cover up those like in very much detail. And now for the model process, like let's actually talk about the model process, like how exactly it works. So again, go back here and let's open up this website if you can. And this is the tensorflow.org. So what exactly this is? So like again you can see like an end-to-end machine learning platform, or like a library basically. So you can see like they are not mentioning this as a DL model or a deep learning model, rather a machine learning model, because we did make this clear. We actually understood like what, like this is a machine learning and this is the part like where actually the DL actually works, and this is your ML. Okay, so how exactly ML actually differs from the DL? Let's see. So whatever we have seen here, like in order like these multi-dimensional arrays, or the training process, or those ways, or the cost functions, the way we actually determine the goodness of an estimation. Well, well, with the help of machine learning, if we talk about the machine learning and deep learning, what exactly the problem is, or how exactly the DL is working. So machine learning is mainly supported only on CPU processes. Okay, and it is like DL supports GPU plus CPU both, and now TPU as well, tensor processing unit. I will gonna come back to it, what exactly the tensors are, just in a while. But this I cannot go into the details of it, like how exactly it actually matters. But for the GPU plus CPU plus TPU, it makes training faster compared to like this ML, like it's training slower, like slow training. When we have larger corpus of data, like when we have large amount of data, well in that case you can actually use deep learning and take advantage of this GPU plus CPU and TPU, like either of those architectures. Okay, second is like it doesn't work well when we have complex non-linearity in our data. Right? So non-linearity basically means, if you remember or if you recall our example from that like mathematical analogy with the neuron analogy, well in that case that is where your ML actually fails at. It cannot create those analogies. So with that, like we can definitely do with the deep learning. Okay, and also uh, it is again like the training is much faster, and we have got more architectures in order to deal with different kind of data, like data types. Like for ML, all we have here like one schematic, okay, to deal with every kind of problem, every kind of data. But in DL we've got different kind of architectures. Like for computer vision we've got CNNs, right? For textual data we've got RNNs. Okay, and for let's say for unsupervised or recommendation systems we have got autoencoders, right? So this is where also your deep learning actually shines, right? Okay, like that is the basic comparison. Like the comparison can just go on and on, but I will not gonna go into that, and we're just gonna stop myself here, right? Okay, so now the ML frameworks you can see like widely used is scikit-learn, and this is your TensorFlow and PyTorch. I have used both actually, and fair amount of like no extension, and yeah, I would rather go with the TensorFlow most of the times, because That is where I am actually most comfortable at, and I always prefer TensorFlow for some reason. So okay, so the TensorFlow is again a machine learning library which enables you to train models, or like makes your algorithm intelligent. Okay, how exactly it works though, this is something subject to the discussion, and which we will just gonna go like just in a while. Okay, so now let's see. So if I go here, I will be literally candid about like how exactly I'll be tackling this problem. Okay, if you have any questions, please quiz me with those questions in the chat, like in the chat box, and I'll be happy to answer those questions like in any amount of number, right? So let's go with this. Get started with TensorFlow. Okay, you can actually follow along. Honestly, you can actually follow along, and let's actually go with this one. Like not with this one, but okay, let's actually go with this one. What exactly is going on here? And you can actually just create this here. Okay, like go for the collab notebook. How to use TensorFlow. That is something I am teaching right now. Okay, create a new notebook. I'm literally teaching you how exactly you can even arrive at on your own solution, arrive at your own solution. Okay, so I'm not here memorizing any code. I'm literally showing you like even if you are like proceeding with your own set of like rules and something, like you can literally go again, just go come to this session or to this video. You don't really have to memorize the code. That is all I'm trying to do here. Okay, so please focus and see. TensorFlow example. Let's actually copy this here. So I'll be doing this, and this is your importing the TensorFlow as TF. So what exactly is happening here? Let's see. So in this case, we are taking or we are making an alias of TensorFlow as TF. So we are referring TensorFlow as an entity as TF, right? Okay. All right. So now, like we have imported the TensorFlow here. Let me actually zoom in a bit. So this is again the TensorFlow library, right? And now, if I just copy this value, okay, I will be doing it one by one. So let me just cut this down here from here, like till here. Let's run this. So in this case, this is the MNIST handwritten data set, like So what exactly this data set is all about? So if I show you MNIST data set, and if I show one of those images, so this is your MNIST data set here. This is a handwritten data set, and you can see like all of those values are digits. If I go back here, I can just okay. So these are the digits which are handwritten digits. Like you can see here. This is 0. This is 1, 2, 3. Like you can see for yourself, right? So what exactly is a task here? Task to determine the digit, okay, through a DL model or deep learning model. That is our task is here. Okay, so so what exactly we have here in number of features? So the features will be your pixel values. Okay, and labels will be this like 0, 1, 2, 3. So if I say here like let us say we've got here, and let us say we have the image as rectangle. This is the frame of that image, assume, and I draw here 0. This is an image. Okay, this is a 0. Like, okay, like this is weird. I would rather draw it as a, let's say this is 2. Okay, this is the image. And now I need to determine by my model, like, and this image will just gonna go into our model, and our model will just gonna predict like if it is 2 or not. Okay, this is something we will gonna build right now. Now, so the label here, or the class label or class here, is what? Is 2. Okay, now let's dig deeper into it, like what exactly is going on. Okay, but the features, because we need features as well. What exactly your features will be? Like, your features will be pixel values. Pixel values, which, all right, no, not which, but that makes this image. Okay, so this image can be further distributed, or can be distributed across uh, rows and column values of each pixel. So it is 1, 2, 3 till 28, and similarly 1, 2, 3 till 28. Okay, so what we have here, and each pixel value will gonna will gonna range from 0 to 255, where 0 is the brightest pixel and 255 is the dark, sorry, 0 is the darkest pixel and 255 is 55 is the brightest one here. Okay, so what exactly am I trying to make a point here? So let's say we've got this image here. Okay, and let us say most of these images, like, most of the values, sorry, pixel values are 0, 0, 0, 0, and 0, 0, 0. And here we have 122. Here we have, let's say, 345, not 345, okay, sorry, 245. And we've got here, let us say, 122. We've got here, let's say, 200. Let's say we've got here 441. Let's say we've got here 225. Okay, and rest of these values are 0. Okay, rest of these values are 0. Assume it. Focus, guys. Okay, so when we have this certain structure, okay, so all of these values, like in this case, if I just focus here, so the brightest region will just gonna outline this region, yes or no? Okay, this will be my brightest region, or like the circumference of those brightest pixels. Circumference be like made by brightest pixel values. It is 0, right? And rest of those values will be what? Like this is nothing but a dark region. So if I draw this image on a canvas, how exactly it will gonna look like? So this will be like this. Like, let's say fill, and I need a black, not a white though, black region. So this is how it will gonna look like. Okay, this will be a black region, and in that black region we will be having a 0. Okay, so I need a, like, and that 0 will be somewhat, will just gonna look like this. Okay, like this is how it will gonna look like. Okay, and that is your image formation which you just saw. So now tell me, is this clear or not to you? Just tell me, like, then I can just proceed forward. Yes or no? Is that clear or not? No, and like not clear. Is this clear to every one of you? When you say no, please make a point, or like, give me a point where I can actually shed some light over. I don't really know what exactly you mean by no, right? So please make a point where exactly you are feeling tripping over, or like you are not being able to understand the concept. All right. So most of the answers are yes, but I am more interested in no's. What exactly is like, what exactly is holding you back there from understanding this concept? So please let me know in that. Like, we have got here constraint. Okay, but I can actually explain here. Okay, so like in this case, what is happening? Like, let us say we need to project this zero. Like, let's say like this is your zero. So in order to visualize this zero in the format of a pixel value, like let's say this is like, how many values do you see here? 5 cross, like 5 rows, and 1, 2, 3, 4, 5, 6, 7, 7 columns. This is a 5 cross 7 image, right? 5 pixels and 7 pixels, 5 by 7 pixel value. So you must have also heard it, or like must have actually seen it. Okay, are we learning about Python, or is this something else? This is machine learning or deep learning in general. Okay. Yes, Abhinav. Yes. Hello, Shiva. Right. And now, if you see here, like this is the brightest region, right? Like brightest value, or the brightest circumference made by the brightest pixels available here, at least in this region. So that is what we are having here. Okay, and rest of the values are basically zero. So the entire background will just gonna look like, like a black region and nothing else, right? Okay, so like that is what I am trying to make here. Okay, and now, so this is, if I plot this data here, let's say import matplotlib matplotlib.pyplot splt, and let's say if I take a sample from xtrain, okay, of 0, and if I print the sample, that is how your sample will just gonna look like. So if you notice here, like if I zoom out a bit, like this actually looks like what, I guess a 3. Like if you notice here, this actually looks like a 3. I hope so, like something like this, like it's a 3. Yes or no? Okay, let's actually plot this out, so like that will be much more apparent, I guess. Okay, and now if I plot this value here, how exactly I can plot it? Let's see. Like we can actually plot this value out with the help of matplotlib. So I can just plt.imshow. Okay, and the sample here, so I just make sure this sample is in grid format. Okay, so if I check for the samples shape as well, it should be in a grid format. So it is 28 cross 28 right now. So if I print the sample, let's print the sample here. So it is a 5, sorry, not a 3. All right, so okay, so like this is actually going like this. So if I print that value again, my bad, literally my bad. So it is actually a 5. I didn't see that, but it is a 5. Okay, and okay, that's fine. And now the label for this is what, like you can also manipulate this value with the help of CMap, and I can just put it as binary. And now if I plt.title, title will be what, white train of 0th value, and I can put this value as a string. Okay, and let us say we've got here 5, and I can also make it as plt.show. So binary basically means I am converting this entire image into a black and white. Okay, and you can also convert this into a gray map. So this value will be into like black and white, the way we actually saw earlier. So just convert it into gray map. And this str white train basically is like the label associated with that sample. In this case, like this is the sample here, and the label associated with that sample was this white train. And since this title only accepts string values, so therefore I had to convert this integer value into a string value. How exactly I did that? By typecasting that value into an str. That is how I did it. And now the next step is this. Okay, so now what am I doing here? Like this is called the normalization of value. So why exactly normalization actually matters? Like it basically reduces the problem of different scales. Okay, let me explain what exactly this is. So when I say here, let us say we've got two features, F1 and F2. One has a scale of, let's say, 200, 300, 400, and 500. and other has a scale of 2, 3, 4, and 5. And f1 is literally, no, is this like equation. If we see the equation, f1 is 100 times more than the f2. So the scale for the f1 is much higher, right? Okay, so what exactly can happen here? So for the weights, if we notice, for the feature f1, the weights will be higher. That is why you have a, no, you are having these higher values, so weights will be higher. Weights will be higher. And if weights are higher, your model might consider or might give the preference to this feature f1 based upon only these higher weights, which is not correct, which basically making your model biased towards f1 feature. So how exactly we can resolve this issue? Well, in that case, you can use what is called normalization. So what we can do here, like what if I actually divide this f1 with the maximum value from this f1? The maximum value from this f1 column is 500. So how can I do it? Like 200 divided by 500. Similarly, 300 divided by 500. 400 divided by 500, and 500 divided by 500. And I can do the same stuff for the f2 as well. So 2 divided by 5, 3 divided by 5, 4 divided by 5, and 5 divided by 5. So the value here will be what? In this case, this value will be like, this will be on the similar scale now. So now f1 and f2 will be what? It will be 0.4 and 0.4, right? And similar stuff. But this is only an example. It cannot be identical at any case. All I'm saying here, the value, if it is here 0.4, it could be here 0.45 or 0.61. But the value will be squashed down between 0 and 1, which makes the scale even for each feature. So your model doesn't get biased for one single feature. So that is why scaling or normalization is important. So that is what is happening here. So since the value of a pixel can range from 0 to 255, and there will be many values in each image which will gonna have brightest value in that case, right? So we need to scale down those values between 0 to 1, so our model doesn't get biased towards one single pixel. Okay, so that is what we are doing here. Like we are scaling all those values here. Okay, and now let me, yes. Okay, we have scaled it, and now let's actually talk about this here. This model here, I will not gonna use this dropout at all. Let's see. And if I say model.summary, let's also talk about this. Okay, so what exactly is going on? So we are taking here a flattened layer, and the input shape is for 28 cross 28. So what is happening? So our input is in the format of 28 cross 28, right? And this is your dense layer, and this is again your dense layer. So let me actually lay down, stack this here. So we have got here these neurons here till 128. So the number of these neurons is 128, and we have got here 10 values as well on the output layer. But on the input layer, it cannot be a grid. It has to be a single vector. In order to have a single vector, we have to convert that vector into a singular, into a single vector. That grid value into a single vector. So how exactly we are doing it, or we are performing it? By flattening it out. That's it. So when I say 28 cross 28, we are flattening these values out into 784 values. Okay. So when I say here, we have got this, we have got this 28 cross 28 image. Okay. We are flattening those values out from 0 to 793. Okay. And now this can be like, okay, now this can be like, how exactly it will gonna work? It will be like x1, x2, x784. This is your input layer, IL. And now this input layer will just gonna feed into what? Those 128 neurons. And then we will gonna have those 10 neurons. Okay. And then obviously the output will be there. Okay. And these values will just gonna connect with each other like this, which we just saw. Right. and it will just going to predict the probability of each class. Let us say we actually output here 2 as an image, which will going to have a 28 cross 28, grid value. So in this case, we will going to have 10 probabilities, P1, P2, and P10. Whichever we're going to have, like let's say this is the probability for 0, this is the probability for 1, and this is the probability for, let us say, 2, P3. So P3 should be the highest here compared to P1, P2, and P10, the rest of those probability. Because why? Because in this case, this image is a 2. And P3 here is representing the probability of a digit being 2. Therefore, I need this probability as highest as possible. Okay, so that is what we are doing here. Okay, so we are flattening it out, right? I just explained why exactly we are doing it. Let's for now, like this activation, what exactly this is. So these activation basically lives in these small neurons. So the way we actually saw those functions, so activation is nothing but a function here. Let's actually not touch upon that factor just now. And this is again an activation. Let's actually, that this activation is responsible for providing those probabilistic values. That's it. That's all you need to know right now. Okay, and when I do that, and this is the summary for that model. Okay, now we just need to train this model here. So how exactly we can do it? Let's say. So this is the compilation of the model. Okay, so like again, this is an optimizer. Optimizer, the way we actually saw a loss function, right? So loss function, and loss function basically will be optimized by this optimizer. Like, it will just gonna help the loss function to reach its minimum error. And the metric is basically the way we actually saw the RMSE, accuracy, like how accurate your prediction is. That's it. That is what we need to perform in the compilation. Let's actually perform this into the compilation here. We have compiled the model here. Okay, let's train it now for 5 epochs. Epoch is basically, in one epoch you train your model, second and third and fourth. Like this is nothing but the training. Epoch is a like the joint term for back propagation and feed forward. I cannot get into that in much more detail, but that is all I can tell you right now. Okay. So when I see that, like, okay, and when I, so you can see it actually reached 98.68% accuracy. And we can even evaluate like how well it is doing on the testing data or unseen data. It is doing, let's just, okay, on unseen data, it is doing 97% with the loss of 0.76. It is quite good, not that bad. So on testing data, like testing is basically for unseen data, and for the training data, it is doing 98%. So it is not that bad. So literally you just trained your very first neural network, and that was your introduction to TensorFlow as well. Okay, so yes, is that clear to every one of you or not? Just let me know in this case. Like any questions, guys? Any questions? Any questions? Like we are pretty much done with today's session. Okay, and tomorrow we'll be tackling 2 problems, that housing problem and that classification problem both. So any questions if you have, please let me know in the chat. $128.10 represents number of neurons, Chaya. Okay, so when I, like, if I show you the architecture again, this is the 128. Like We have got here 128 neurons and we have got here 10 neurons. Okay. Hello, sir. I'm 27-year-old and I started learn Python. Am I late? It's never too late. Uh, just to clarify, I'm also 27 and it's never too late actually. Okay, and I'm 27. I'm learning how to play guitar, and like it's your brain is capable of learning anything at any given time. So if you have if you have that convention, I would say, or conviction, sorry, so you can learn anything. Got it, sir. Thank you. The stream crashed. What is dense? Dense is a fully connected layer. Thank you for asking this question. This is actually a good question. Dense is a fully connected layer. So dense is another name of fully connected layer, FCN. When we connect each neuron with each neuron. The stream crashed. What? Is it? I don't think so. Like it is running right now. Hello, Oshin? Hello, Oshin? Am I not audible right now? Okay, I am. Yes, you are. Thank you. All right. So this is it for today, guys. I hope you learned something new. I hope you learned something valuable. And I'll see you tomorrow. I'll see you this time. Till then, please take care. Bye bye and good night. Take care. Bye bye.